Amazon and Facebook just asked this question. We're given the array of non-overlapping intervals. For each interval, we have the start and end. The array is sorted in ascending order by the start. We need to insert a new interval to the intervals such that to make sure the graph is still sorted in ascending order by the start and there's no overlap. For example, if you are trying to insert a new interval 2 and 5 into 1, 3, 6, 9, you'll find that there's an overlap occur, so therefore the output is 1 and 5, 6 and 9. If you check out the other examples, given the intervals here, we have 3, 5, 6, 7 and 8, 10. Initially there's no overlap, but if we introduce a new interval, then we can clearly see that 4 is being inserted into 3 and 5, this interval, and then it covers all the way to the 8, so it will link all these intervals together and becomes 3 and 10. Next, I'm going to talk about linear search and binary search, which takes OM time in the worst case. The linear search is following the 3 steps. The first step is if there's no overlap, then we append to the result. And we will continue to do the first step until we find out there's an overlap. If we look at these intervals here, the first item 1 and 2, there's no overlap with 4 and 8. So we just simply append to the result. After the first step, we'll move to the second. We will continue to find if there's an overlap. If it does, then we will merge. So let's say we are on the second item here, 3 and 5. We'll merge into the 4 and 8. So this will become 3 and 8. Now 3 and 8 will be merged to the next element because there is an overlap. And we continue to check if there's an overlap between 3, 10 and then 12, 16. Apparently there's no overlap. So we add 3 and 10 to our result. The third step is to continue to append whatever the items left to the result. Because the array is sorted, and we note from the second step, we already merged all the overlap, so we guarantee there's no overlap after it. And here's the Python code. Notice that the way we check if there's an overlap is by checking the new interval at the first item, which is the start. If it is greater than the end of the interval. So if this is true, that means there's no overlap, and we append to the result. We increment I by 1. The index I is for traversing the intervals. The second step is to merge the overlapping ones. And the way we check if there's an overlap is by checking the end of the new interval with the start of the current interval. So if the end is greater than the start, in this case 8 is greater than 3, then we merge them. And then we check 8 is greater than 6 and we merge them as well. We check 8 and 8, they're equal, so we also need to merge them. And the way we merge the item is selecting the min element between the start. So those two items merge, they will become 3 and 8 because that means the minimum of the start, 3 and 4, and the maximum of the end. So eventually we'll get an 8. We need to finish the second step and we continue to merge to the variable new interval. After we found out there's no overlap, that means we jump from the while loop. Finally, we append to the result. The third step is to simply append whatever left. From the step 1, 2, and 3, that means we traverse all the intervals array, so the time complexity is O(n). Next, I'm going to talk about the binary search. The first step is to find the index so that we can insert the new interval to the index. You can just call the binary search library, or you can implement the binary search from scratch. That way you can impress your interviewer. Let's implement the binary search. You need to declare the left index to be the first element of the array, the right index to be the last element, and the middle index, that means L plus R divided by 2. We need to compare the start of the new interval with the start of the interval at mid index. We know that 4 is less than 6. That means the new interval should be inserted on the left side of the mid. We need to move the right index to the mid minus 1. Now we know that the mid index is at 0 because 0 plus 1 divided by 2 is 0. By checking 4 and 1, we know that the new interval should be on the right side of the mid. So we need to move the left index to be the mid plus 1. We continue to check the new interval with the mid. We know that 4 is greater than 3. That means the new interval should be on the right side of the mid. So we moved the left to be the mid plus 1. Now the left index is greater than the right. That means we are breaking the while loop of the binary search. And we need to add the new interval to the index L. And here's the Python code. The binary search will take O log n time. After the binary search, we insert the new interval at index left from the binary search to the intervals. And this is the step 3, that we traverse the array and merge the overlap. Notice that I add the first element to the result because I need to compare the new interval with the last of the result. If there is an overlap, I reassign the merge result to the last element of the result. I know we have a log n in the binary search, but the third step is actually taken O(n) time. If you like this channel, please click like and subscribe. Thank you.